Welcome to the session, my dear students. In this session, we'll continue with problems. Here, the classroom workbook, 16th problem. Classroom workbook, question number 16. Okay. It was also asked in GATE. Find I1, I2, I3 and the powers developed in 10-volt source is asking. Okay. So let us find. First note down this question. All of you draw it. Okay. If you draw the network, here 2 ampere, this is 10 volt. Here it is given I1, right? And this is given I3. And this is given I2. Okay. So now you are expected to find what in this question? I1, I2, I3. The first question is what? I1, I2 and I3. Power developed in 10 volt source. So you are supposed to find these two. And let's see how we are going to find it. So I think I can take it off, right? Okay. Whenever you come across a network, I told you a standard procedure. Is it a single source network or a multi-source network? Multi-source network. For multi-source network, node analysis or mesh analysis is the best method. Yes, sir. For a single source network, either current division or voltage division. For them, even we have given an alternative approach. Wherever current division, voltage division is possible, there even jumping technique is also possible, right? So now this is a multi-source network. Let us think about now mesh analysis or node analysis. If you go for mesh analysis, 1, 2, 3, okay, 3 minus 1, 2 equations. For that, the selection of loop currents must not be like this. But already these currents are defined in the problem. Understand, okay? But if you want to select, if you want to get only 2 equations, what must be the selection of loop currents? I1, I2 and I3 must be selected like this. So that this particular current source will experience only one loop current. Understand? This is what? The minimum number of equations you will get what? 1, 2, 3, 3 minus 1, 2 equations using mesh analysis. But what is the node analysis? If you go for node analysis, 1, 2, 3, 4, 4 minus 1, before you conclude that, check. Yes, there is a voltage source doesn't have a resistor, voltage source doesn't have a resistor, n number of nodes, n minus 1 equation fails. It all depends on the selection of reference node. Obviously, when these two are sharing a common node, better you select this node as a reference node so that immediately you can confirm this is 12 volt and this is going to be 10 volt, and out of these 4 nodes, 3 nodes are defined now and this is the only node which you do not know. Minimum number of equations required to solve this network is only 1. Yes or no? Okay. Now let us solve it. Shall we go with inspection? V of 1 by 4, 1 by 6, okay, 1 by 4, 1 by 6, that's all. Okay, there are only 2 passive elements of, okay, 12 by 4. I told you already, this is a special case. This node voltage is a constant, 12 by 4. You can't take 12 by 2 because this 2 is not related to V. Whatever the element connected between the constant voltage and the node variable, that must be taken. Here, constant voltage node variable, that is 10 by 6. You understand? Okay, plus 2 ampere. Plus 2 ampere. From this, you find the value of V. Understand? You find the value of V. Okay. Let's find the value of V. After finding V, you are supposed to find what? I1, I2, I3. They are the loop currents, but the loop currents are going to be somewhere branch currents. Understand all of you? Where is the branch current here? I2 is the current flowing through 2 or not. So indirectly is asking what is current through 2 ohm or current through 2 volt. I1 is current through this loop, nothing but current through 12 volt, because this element belongs to only first loop. This element belongs to only second loop. Therefore, the element which belongs to the first loop, its branch current is same as its loop current. The element which belongs to only third loop, look at this. Okay, the current flowing through the 10 volts will become what? I3. That means indirectly is asking what is current through 10 volt, what is current through 12 volt, what is current through 2 volt or 2 ohm. That's it. Yes or no, all of you? Okay. So note it down quickly and just find the value of V. What is the value of V? Okay. So quickly calculate that. Quickly calculate that. Okay. So you get, now the value of V is nothing but 16 volt. Understand all of you? Okay. Now let us try to find I1, I2, I3. Hope you have noted on this, all of you. Okay. And let's go with that. I have calculated. Okay. Then I got this 16 volt. What about I1? I1 is the current flowing here. What is the current through any path? What is the procedure? Resistor? No. Then go for KCL. If there is a resistor, Ohm's law, otherwise KCL. So let's go for KCL either at this node or at this node, doesn't matter. So let me apply KCL at node A. KCL at node A. KCL at node A. Tell me, I1 is entering, right? I1 is entering. Okay. 12 minus V by 4 leaving. 12 minus V by 4 is leaving. 12 minus 10 plus 2 by 2. 12 minus 6, that is 4. 12 minus 6, that is 4, that is minus 4 by 4 minus 1 plus 12 minus 10, that is 2, 2 plus 2, 4, 4 by 2, 2. So finally you got 1 ampere. Okay. Now I2. For I2, you don't need to apply KCL because I2 is the current flowing through this path where there is a resistor. Now apply Ohm's law to it. Apply Ohm's law means what? This is operating at 12 volt. And this is operating at what? 10 minus 2. Yes or no? 10 minus 2. 10 minus 2 is nothing but what? This voltage is operating at what? 8 volt. Yes or no, all of you? Okay. So 12 minus 8 by 2. Or else people call it like this. 12 minus 10 plus 2 by 2. That's nothing but what? Potential difference only. This is 12. Okay. This is 8. 12 minus 8 by 2. How much it is? 2 ampere. Or else 12 minus 10 plus 2 by 2 is also 2 ampere. Yes or no? So that is why I told you Ohm's law you are applying. That is Ohm's law is nothing but what? 12 minus 10 plus 2 by 2. That is nothing but 2 amperes. Numerator is the potential difference across the denominator only. That's why I'm telling you always when there is a resistor you apply Ohm's law. This is nothing but Ohm's law only. I3. I3 let us find. What is the procedure to find I3? To find I3, look at this. This is the current flowing through 10 volt. Yes or no? Loop current is going to be somewhere branch current. Yes or no? In which branch that current flows? Whichever the branch belongs to that particular loop. This is what the loop actually belongs. This is what the element which belongs to only this particular loop. So I3. Now there is no resistor in the path. Standard procedure. There is no resistor in the path. Therefore go for KCL either at this node or at this node. Let me apply at this node. Node B. KCL at node B. KCL at node B. KCL at node B. Tell me, what will happen? I3 is leaving. Okay. V minus 10 by 6 entering. Then, what about this? This is I2 only, right? This is I2 only. That is also entering. 12 minus 10 plus 2 by 2. This entire value is 2. Okay. And V is nothing but 16. 16 minus 10. How much it is? 16 minus 10. That is 6. 6 by 6. 1. 1 plus 2. That is 3 ampere. So finally you got these values, right? Now, another question is what? Power of 10 volt. Yes. What is the power of 10 volt? Okay. What is the power of 10 volt? You already got this, right? Okay. Power of 10 volt. Power of 10 volt is nothing but 10 into, what is this? I3. What is I3 value? 3 ampere, 30 watt. But what is this current doing? Entering into positive. You must mention it as absorbed power. Understand? Sometimes in the 4 options, okay, he will give you 30 watt supplied, 30 watt absorbed. Like that he may be giving. So be careful. Always whenever you find the power of any energy source, it's always a good habit of writing whether it is supplied power or absorbed power. In the 4 options, if it is not given like that, then you can proceed according to the options given. But always a good practice to write. Okay, so please note it down quickly. I'll give you some time. It was also asked in GATE. It was also asked in GATE. So now let us be very clear. When the problem is given, which method is the best method and how to really solve it in less amount of time. That is our target. And I'm telling you, when you have a network, you have only 2 options. Unnecessarily don't break your head. Okay, just always think with respect to either node analysis or mesh analysis. Most of the times, 99.99% the problems can be solved by node analysis. I think by this time you might have already realized. Okay. Now let us look at this. All of you, 17th question. You can also note down the network. Quickly draw. Now, what is asking actually here the question? Please read that question. The question is, the power supplied by the voltage source is. The power supplied by the voltage source is. Yes or no? The power supplied by the voltage source is. Read the question. The power supplied by the voltage source is. Some options were given. Okay. Let us see now. Forget about whatever is asking for a moment. We'll come back to that later. First, our focus must be on what? How to solve a network. That's it. You have 2 options. Mesh analysis. 1, 2, 3. 3 minus 2. 1 equation. No doubt. Only with 1 equation you can solve using mesh analysis. Node analysis, please. 1. Okay. 2. 3. 4 nodes. This is degree 2. I don't need. Degree 2. I don't need. Degree 3. I need to locate the node. 1, 2, 3, 4. 4 minus 1. No, let's not come to that because there is a voltage source without any resistor. N number of nodes. N minus 1 fails. Now, if you select this one as 0, then this becomes what? 10 volt. And this is unknown V1. This is unknown V2. That means the minimum number of equations required using node analysis is what? 2. Using mesh analysis 1. Finally, what are the minimum number of equations required to analyze this network? 1. That means for this problem, okay, Mesh analysis is the best method because that is giving the less number of equations. But for a specific reason, I choose node analysis to solve this problem. Okay? Not that I love node analysis, don't think like that. Okay? I'm applying the node analysis, or I wish to apply the node analysis here for a specific reason. If you observe closely, look at this. If I take this one 0, look at this. If I take this one 0, what is it? 10 volts, right? What is it? V1. What is it? V2. There are two variables now. But two principal nodes between which there is an ideal current source connected. When there is an ideal current source connected between two principal nodes, okay, the two equations will become independent. What do you mean by independent? That means V1 can be determined just by applying Kirchhoff's current law at that node itself without finding the value of V2. Similarly, V2 also. V2 can be determined without knowing V1. V1 can be determined without knowing V2. So that is a very important point to be noted down here. Note, put a note and write down here. When an ideal current source, write down this, when an ideal current source is connected between two principal nodes. When an ideal current source is connected between two principal nodes, the node equations will become independent. The node equations will become independent. The node equations will become independent. I think all of you noted on this point. Now let us look at the equations. You will understand. Look at this. V1 minus 0 by 2. V1 minus 10 by 2 plus 1. That's it. Do you have any V2 in that particular equation? That is why I told you that equation will become independent. Here also you apply the same thing. V2 minus 10 by 1 minus 2 minus 1. That's it. When you write KCL at this node, there is only V2 term, there is no V1 term. When you write KCL here, there is only V1 term, but there is no V2 term. Therefore, that's why I told you the equations will become independent. If you write those equations here, okay, V1 by 2, V1 minus 10 by 2 plus 1 ampere. That's it. Though it is giving two equations in node analysis, though it is giving what? Two equations in node analysis, okay, but since the equations are independent, it is as good as two single independent equations solving, right? That is why, though I understand that it is giving two equations in node analysis as compared to mesh analysis, okay, as compared to mesh analysis, what's happening? One equation is extra, but still I am not worrying about that because the equations are independent. That is why I am just choosing node analysis here. So this is a very important observation. In a given network, you can easily identify that. When there is a current source between the two principal nodes, you are lucky because the equations will be easy to solve. There is no need to go for Cramer's rule. Look at this. Without Cramer's rule, I am finding here. I can find what is V1 value. Okay, next. So what is this now? You can observe that later on. Okay, now you apply KCL at this node. What is this? V2 minus 10 by 1 and minus 2 minus 1 is equal to 0. Okay, from this you can find what is V2. So what is it actually here? Then I think you get 13, right? 13 volts. This is 13 volt. And 1 by 2 plus 1 by 2, 1, that is 10 by 2. Okay, minus 1. You can find that value directly here. This is simply V1 of 1 by 2 plus 1 by 2 is equal to 10 by 2, okay, minus 1. 10 by 2 minus 1 is nothing but 4. This is simply 4 volts, okay. This is 4 volts and this is 13 volts. Yes or no? Okay. Minus 10, minus 12, minus 1, minus 13. Then finally you have got 13. Then you need to find what? the power of this particular voltage source. Power of voltage source, if you want, you must know the current. What is the current? I do not know. Let me assume some current Ix. Sir, how do you know the direction of current? I do not know. I just assume some current direction. That's it. I just assume some current direction here. Okay. So Ix is the current flowing here. And because there is no resistor, let me apply Kirchhoff's current law here. KCL at node A. KCL at node A. Okay. KCL at node A. Right. So if you apply KCL at node A, what do you get? Ix is leaving. Okay, 10 minus V2 by 1 leaving. Ix is entering, I'm sorry, Ix is entering, but 10 minus V2 by 1 is 10 minus V2 by 1 is leaving. 10 minus V1 by 2 is also leaving. 10 minus V1 by 2 is also leaving. So 10 minus, this is 13, right? 13 by 1 plus 10 minus 4 by 2. So this is 6 by 2, right? 6 by 2, 3. But this is minus 3 plus 3, 0 ampere. Therefore, the power of the 10 volts will become, okay, 0 watt. That's it. Please note down this. Please note down. Hope all of you understand that statement. So that's a good opportunity when you have an ideal current source between two principal nodes. Understand? Okay. So question number 18. Please complete them. Meanwhile, I will just give one more problem here. Question number 18, classroom workbook. Classroom workbook. Question number 18. It's very important and interesting problem. Okay. Please draw this network after completion of that particular part. Look at that question, what is asking here. Okay. Okay. So okay. So 5 volts. We have 1 ohm and 2 ampere. What is the question? If VA minus VB 6 volt, then VC minus VD is how much, right? So very simple question it is also. The network looks like a complicated one, but the solution is very simple if you can get the point here. Okay. A, this is B, C, this is D. If VA minus VB is equal to 6 volt, then what is VC minus VD? That's it. Some options are also given, okay? But always practice without looking at the options, I'm telling you. That is always a good practice. Because I told you already several times that GATE consists of more than 60% of the questions are fill in the blanks. Understand? Now, observe that network carefully. It's very clear that R, some R's are given here, right? It doesn't give any information regarding R. What does it mean? When R value is not given at all, okay, I understand that this problem doesn't require the R value. There is nothing to do with the R value here, okay? Most of the people start simplifying the problem, series, then parallel, or some star delta transformation. Please do not do such kind of things here. Because it's very clear that the problem is nowhere concerned with the R value. That means there is no need to reduce that. But what is the data given? If VA minus VB is 6 volt, then what is VC minus VD is asking? Okay? Whenever the problem is given, because I am repeatedly telling that you have only two options, mesh analysis, node analysis, that's fine. But sometimes even without mesh node analysis, from the data given, you can easily simplify it. Okay, you have to understand first of all for this problem node analysis, mesh analysis is required or not. Look at this. He's asking VC minus VD. That means it is a voltage across 1 ohm. Agree or not, all of you? All of you agree with me? Voltage across 1 ohm is nothing but voltage across CD. If you want to find the voltage across 1 ohm, you must know current here. How much current is flowing here? Please don't say this is 2 ampere. Okay, because this current is not exactly flowing through 1 ohm. Now there is some more current here. There is a connection here. Please realize this, all of you. There is a connection. If there is no connection, if current flowing here is 2 amperes, I agree with you. But there is a connection. There is a connection. Understand all of you, okay? Now, what do you do? The voltage across the 1 ohm, if you can find, it's nothing but voltage between CD. But to find that, you must know current here. To know the current here, definitely you must know current here. You understand all of you? If you know current at this point, this current and this current, how much current here is? It is 2 ampere. How much current is flowing? Let us find that. Both the current resultant will flow in this path. Yes or no? For that, let us look at the data given. What is the data given? Plus minus 6 volt. How you plus minus? VA minus VB. A is higher. 6 by 2, how much it is? 3 ampere. If 3 amperes is flowing here, treating this one as a subnetwork, at each subnetwork KCL must be satisfied. This statement was given when we solved the problems in the fundamentals. Okay? Problems and fundamentals. At each subnetwork KCL must be satisfied. Then if this is 3 ampere, then obviously this is what? 3 ampere. If this is 3 ampere, obviously this is what? 3 ampere. The direction is very clear. 3 ampere is entering, 3 ampere should leave. 3 ampere is leaving from this node, then 3 ampere should enter. Anything is okay for us. So this is 3 ampere, this is 2 ampere. If you apply KCL here, how much is flowing here? If you add 2 plus 3, this is 5 ampere flowing. 5 into 1, you get plus minus 5 into 1 volt. That's it. Now, you got negative and positive, but he's asking VC minus VD. That means C is at higher. That means there is a mismatch. Therefore, VC minus VD will be just simply minus 5 volts. Hope you understand this point, all of you. This is the way you need to think when the problem is given. Okay? I told you that when the problem is given, you have only two options, multi-source network. Okay, agree. But sometimes a simple data is given without any solving the network, you can find the answer. So such kind of things you must be in a position to identify. Please do that. Do that quickly. Meanwhile, I will note down another problem here, okay? 19th problem. Classroom workbook, question number 19. Question number 19. Classroom workbook, question number 19. First you finish that, all of you. I think all of you understand that. So at each subnetwork KCL must be satisfied. Treating this one as subnetwork. Okay. Let me write otherwise, so that tomorrow you can refer the notes. When you refer the notes, you must understand. KCL must be satisfied. Okay. Question number 19. It was given in IES. Okay. Okay. Read the question. What is asking? Ix and Vx values is asking yes or no. Question number 19. It's just asking Vx and also Ix. It's a very simple problem. Look at this, all of you. So again, Ix, Vx, okay, whatever is asking here, let us keep them aside for a moment. Let us focus on how to solve the network using mesh or node, multi-source network. So this value is actually given as 3 ohm, okay? 3 ohm. This is 3 ohm. Please note down 3 ohm. Mesh analysis, if we go 3 minus 1, 2 equations. Node analysis, if we go 3 nodes. If you take 1, 0, then 2 equations required. Using mesh 2, using node 2, minimum number of equations required to analyze this entire network is also 2. But I still prefer node analysis. What is the reason? Again, don't tell that, I like node analysis. No, not like that. There is a specific reason for that. If you take this one 0, this is V1, let us say, this is V2, let us say. But look at this. This is a golden opportunity that you can go for the transformation. Once you transform, all these elements will become series. Even without this variable, you can solve the entire network. One single variable. But minimum number of equations required 2 only. Okay, for that question, that answer is 2 only. But when we are getting an opportunity to solve the network, you must utilize the source transformation properly. And okay, use only one equation to solve it. What is this 7 5 ja? 35 volts, right? This is 5 ohm. Now this 5 ohm and 10 ohm are in series, don't forget that. Now V1 of, I can say V1 of 1 by 3, 1 by 2, 1 by 10 plus 5, 1 by 15, yes or no? Okay, is equal to, what is this? Now minus 20 by 2, minus 20 plus 35. Minus 20 plus 35. Minus 20 plus 35 by 15, right? Now tell me here, this is 10. 35 minus 20, 15, 15 by 15 is 1. Okay. Now V1 off. This is 30. Okay. 10 plus 15 plus 2 is equal to, what is this actually here? So you got minus 10 and 1. I think you get, okay, minus 9. Yes or no? So what do you get here? 10 plus 2, 10 plus 2, 12, 12 plus 15, 27. So 3 ja. Okay. So 3 10 ja. Finally you get V1 is equal to minus 10 volts. Understand, all of it is a simplification part. One must not do any mistake in this. So what is Ix now? Ix is equal to V1 minus 20, right? V1 plus, I'm sorry, V1 plus, because this is minus plus, right? This is taken as 0 already. V1 plus 20 by 2. So minus 10 plus 20 by 2 will give you 5 ampere. And what is Vx? Vx is 2 into 5. He didn't mention any polarities, so don't worry about the polarities. Simply 10 volts. Do that, all of you. Meanwhile, I just note down another problem, okay? So please quickly do that. Always utilize that opportunity when there is a current source. When there is a current source with a parallel resistor, don't miss that opportunity. You can reduce the number of equations using node analysis. Question number 20. I'm just drawing the network. All of you finish that and then come back to this question, okay? So what is the option here? A. Option A is correct, right? Option A, it is given as 5 amperes and 10 volts respectively, okay? This question was also given in IPS again, okay? The question is find V1, V2, okay? V1, V2. Okay? Find V1, V2, plus minus. Point 0.5 V1, 5 ohm, 10 ohm, 20 volt, 2 ampere. Already defined, this is 0 and this is V1, this is V2. Asking V1, V2 values, okay? So, apply node analysis directly. There is no other option, no doubt. Go for mesh analysis, 1, 2, 3, 4. Yes, 4 minus 2, 2 equations, plus V1, V2 are the two dependent variables, okay? V1 is a dependent variable, not V2. Okay, V1 is a dependent variable, another equation. So 2 plus 1, 3 equations. If you go for node analysis, 1, 2, 3, that is V1, V2. But because the dependent variable and node variable both are same, therefore you don't need to go for any extra equation. So let's go for that. Minus 2. V1 minus 20 by 10. I give you the answer directly. You have to solve it at your home, okay? You just get the answer after solving these equations. I'll give you the answer, don't worry. V1 minus V2 minus 0.5 V1 by 5 is equal to 0. This is equation 1. Okay, V1 minus 20 by 10 minus 2, V1 minus V2 minus 0.5 V1 by 5. Second equation, please. V2 minus V1 plus 0.5 V1 by 5. Okay. V2 by 2 minus 5 plus V2 minus 30 by 10. Second equation. Solving 1 and 2, you get V1 and V2 values. I just give you those answers, okay? All of you please note down, okay? You must be good at solving the equations, right? So I give you 34.285 volt and 14.285 volts. So please note down this quickly. Please note down that quickly. Meanwhile, I'll just give you another problem, okay? So you can do that easily. Those are the equations you are getting. Only thing you have to solve them. I gave the answer. You please cross check. At your leisure time you solve them and just cross check the answers. Okay. '21. It was asked in GATE. Okay. What is the question actually? Potential difference between P and Q. Yes or no? What is this value? 2 ampere, 2 ohm, 4 ohm, 10 volt, right? 8 ohm, 6 ohm. This is P, this is Q defined here, okay? Now what is the potential difference between P and Q? Some options are given, okay? Let us not worry about the options here. Without options, we must be in a position to solve. I told you already. Now, go for mesh analysis 1, 2, 3, 3 minus 1, 2 equations. Go for node analysis 1, 2, 3, 4. Don't come to 4 minus 1 conclusion because there is a voltage source which doesn't have a resistor. If you take this one 0, this is 10 volt, then still you get 2 equations. Mesh analysis will give you 2 equations. Node analysis will also give you 2 equations. But still I am preferring. What? Okay, I'm preferring what still? Node analysis. What is the reason for that? Okay, there is a specific reason. Just now I have explained to you that between two principal nodes, there is an ideal voltage source. The equations have become independent. It's easy to solve for you. Yes or no? Okay, therefore, tell me now what is the equation you get when you apply KCL at node P? KCL at node P. Okay, if you apply, tell me VP, this is VP and VQ. VP minus 0 by 8, VP by 8. VP minus 10 by 2 plus 2 ampere is equal to 0. This you get VP value. VQ by 6. VQ minus 10 by 4. Minus 2. From this you get VQ value. Here you can say VP of 1 by 8, 1 by 2 is equal to 10 by 2 minus 2. Here you can say VQ of 1 by 6, 1 by 4, 10 by 4 plus 2. 10 by 4 plus 2. Okay, so what do you get? Just solve them. Just solve them here. I think you got 2 5s. So this side you get 3. Yes or no? 1 by 8, 1 by 2. You have to solve it. So let me give you by calculating here. I am with a calculator here. You can also do it meanwhile. This is going to be 4.8 volts. All of you please do that. One by 6, 1 by 4. Yes or no? 1 by 6, 1 by 4. Into, that's it. So this is 10.8. Yes or no? This is 10.8 volts. So what is now potential difference? Potential difference nothing but what? Either VPQ or VQP. Because he did not mention, just only difference he said, right? So VPQ or VQP doesn't matter, but potential difference means generally we take a positive value. Or sometimes in the options negative value also he might be giving. But generally when he's asking potential difference, he doesn't give you one minus the other plus. Same value with minus plus polarities, he doesn't give that answers. Because he is very clear that potential difference is asking. So what is that now? 4.8 VPQ, if you take 4.8 minus 10.8, this is minus 6 volt. Do you have any option that is minus 6 volts? Yes. Okay, but never expect the options like minus 6 volts plus 6 volts like that. If he is asking what is VPQ or is VQP clearly, then he will give minus 6 plus 6 also. But if he is asking, let us say, potential difference, he doesn't give you minus 6 plus 6. Either he will give minus 6 or plus 6, that's it. Even in the options with instead of minus 6, if you have plus 6, that is also correct options because just potential difference. Okay. So this is all. Okay. Some problems we have done, almost 21 problems we have done in this session. Okay. So we have done good number of problems. Okay. So I'll stop the session here and we'll discuss the remaining things in the next session. Okay.